Welcome to the solutions to the AP Physics Equilibrium problem set, problems number 6 and 7. Let's start with 6. Find the tension in each cable supporting the 600 Newton cat burglar shown in the diagram below. As always, how we start these types of problems is by drawing a free body diagram of all the forces acting in the system. And here we have the weight down, which is the 600 newtons given. We have a tension in this cable to the left, which we'll call T2. And we have this tension in the cable up at an angle of 37 degrees below the ceiling, which we'll call T1. That would be the free body diagram in this problem. We kind of have a little cable right here, but we understand that the 600 newtons down and that tension in that cable are the same, so we really don't need to solve for that one. We're just looking for the tensions in T1 and T2. At this point, we would also sketch in the components of any forces at angles. So we'll sketch in this one, which is T1 cosine 37 degrees. And this component would be T1 sine of 37 degrees. All right. Now we need to consider, are there any directions in this question for which we would be able to summate forces and be able to get in one of those answers in one step? If we take a look horizontally, we have both T2 and T1 as unknowns summating horizontally. But if we look vertically, we see that we just have T1 as an unknown and the weight down, which we do know. So it makes sense in this problem that we start off just summating forces in the y direction. And of course, the object, the cat burglar, is not accelerating, so the summation of forces vertically is 0. The summation would be T1 sine 37 minus mg equals 0. And it doesn't matter which direction you pick as positive here, as long as you're consistent in your summation with those forces. So we have T1 sine 37 degrees, adding the weight to the other side, and we're told that the weight was 600 newtons. Solve for T1, and we get a value of 997 newtons. Now that we have this answer, we can go ahead and summate forces horizontally, because now we know T1 and we can solve for T2. So now we summate forces in the x direction. Cat burglar is still not accelerating in the x direction. He's in equilibrium. All forces are 0. So add up, summate to 0, that is. And our summation here doesn't, again, matter. We can go T1 cosine 37 degrees in the positive direction minus T2 equals 0. So T2 would be T1, which we solved to be 997 newtons, times the cosine of 37 degrees. And our second tension, when we calculate, would be 796 newtons to 3 digits. All right, there's the solution to number 6. Let's move on to number 7. Find the tension in the 2 wires that supports the 100 Newton light fixture shown in the diagram below. Once again, we start off by drawing a free body diagram. We have the weight down, which is 100 newtons, so mg equals 100 newtons as given in the problem. What we also note in this problem is that 2 wires are both at the same angle below the ceiling, and so we recognize that the tension in both these wires would be identical because they meet at the midpoint Actually, the length doesn't matter, but they're both the same angle below the ceiling, so they're both going to have the same tension. This would be the free body diagram in this system. And what we're going to do now is sketch in the components as well. This would be T cosine 40. This component would be T sine 40. Component on the left would also be T sine 40. And this component would be T cosine 40. What we can see horizontally here is that the two horizontal components cancel each other out. So this answer is fairly easily attained by simply summating forces in the y direction and the vertical direction. The light fixture is not accelerating, and so our summation could look like 2 times the T of sine 40, since we have two components up, minus the weight down, equals 0. So T2 times the quantity T sine 40 equals the 100 newtons. Solve for T, and you should get 77.8 newtons to 3 digits. Okay? All right, more to come on translational equilibrium problems in class tomorrow, as you'll be working to solve problems 8 and 9.